Siang, or you can call me Benny. I'm very honored to present my study titled Feasibility Studies of Expandable Mobile BSL-3 Laboratory, or EMLAB in short. So let us begin. Yep. First of all, in this presentation, I'm going to cover basically 4 topics. The first is the concept background, why this concept exists. And then secondly is the existing model and pattern that I have reviewed in the work. Third is the technical aspect that this concept has to tackle. And lastly is the design propositions that I have concluded in this feasibility studies. So the first question that comes in mind when I started this project is this: is lacking access to urgent medical service lethal? In some scenario that talks about second to second, yes, it will be lethal. Unfortunately, these situations is very common among the underprivileged community among Sabahs. According to statistics, there's more than 80% of the rural communities from Sabah stays 5 kilometers away from the nearest medical facilities. The tragic of Kamagong is the worst scenarios that happens. In 2008, Kamagong, a mother, died due to postpartum hemorrhage. She herself stayed more than 5 hours away from the nearest maternal facilities. This pretty much shows how severe it can be of medical inaccessibilities among the poor communities. Along that, recently in May, there's a severe spikes of COVID-19 death on arrival cases. In May alone, there's around 81 cases of DOA cases out of 217 found this year. The biggest reason is that most of these cases are untraced or late detections. They are saying that we need more testing at a faster pace, higher capacity of lab testing. And the third is the comparison between Sierra Leone Ebola outbreaks and Sabah's COVID-19 outbreaks. Back in 2014, Sierra Leone have a severe Ebola outbreaks that pretty much bottlenecks their medical systems. The diagnostics waiting time of that sample can take as long as 5 days due to overwhelming test sample. Unfortunately, similar situations happen in Sabah. Back in last September, we have one of the first wave of COVID-19 outbreaks. A big majority of the samples has to be sent to Peninsular Malaysia to speed up the process. So this comes in mind. We're proposing one concept called EMLAB to solve these solutions. So what is Expandable Mobile BSL-3 Laboratory? There's 3 main markers and directions that pretty much sets our starting point in this project. First, it must be transportable. Yeah, this criteria coincidentally it fits what our previous keynote speaker, Mr. Mauricio, about the need of architectural reformations. In here, I am proposing using a modular structures. The biggest reason is that it is easily transportable. Secondly, energy efficient. And then third is also taking less time consuming, and provided the manufacturing systems is well established. Yeah, this is the first thing. Secondly, in this EMLAB concept, we are targeting on incorporating expandable features like providing more spaces. In the past, there are studies that shown similar structures has limited spaces for higher efficiency. It is also reflected on patient satisfaction. So in this project, we want to incorporate that. Lastly, regarding the laboratory, we are not aiming for the standard BSL-2 or BSL-1 laboratory. BSL-3 indicates that this structure itself has to be containable for a higher and higher degree, higher risk is pathogens research. It has to be airtight to prevent the potential leaks. So this markers as the foundations. So prior to the design, I have studied several existing models and patterns prior to the studies. In the market, basically there's several form factors that engineers adopt to design a mobile laboratory. First is the vehicular structures like van, buses, trucks. These are inherently transportable. They just fit whatever crucial in a laboratory features and make use of the space. Secondly is like modular building structures like shipping containers. Last year, China's also built a hospital, COVID hospital in 10 days. They uses mobile modular building to speed up the processes. This pretty much marks the efficiency of the structures. In this product, there's one limitations. The first is the space limitations. In most of these, is engineers oftentimes have to cut corners, dare I say, or sacrifice certain features. The standard practices, in example, the ventilations, connections, etc., that would definitely reduce the risk of cross-contaminations among the lab processes. This may be compromised or less efficient, dare I say. So, there's two main examples that are pretty relevant to what I'll be proposing later. The first is the mobile BSL-3 produced by China. This model itself is adopted in 2014 during the Sierra Leone outbreaks that I have mentioned. And what is this model? They use 3 shipping containers to separate into 3 distinct modules. First is the laboratory. Second is the auxiliary that provides like water treatment, power generations, and then the last one is the telecommunications. What the special point is that they know that one container itself they cannot carry it. They systematically plan it on the form factor existing, and so that it makes it transportable. Then after I look into another patents by the Hungarian Ministry of Defense Electronics. This is the only patent that I found so far that pretty fits what the criteria that I have. It features expandable features, but after I studied through it, that's one limitation. The expansion doesn't provide any additional laboratory workspace. So this is something that I want to tackle. The additional space just serves for the public internet access spaces that doesn't really require high sanitary standards. Yeah. So in order to fulfill the EMLAB concept, there's 2 things that I have to.
So you have 2 minutes to conclude.
Okay, I'll speed up. Okay, first of all is the expansion features. What to use, which is I can conclude there's 2 types: telescopic and the hinge and lever mechanism. The hinge one is the most common one. However, these 2 methods there are pros and cons. So the second thing is the airflow settings. That how can we make it a clean room, prevent minimal cross contaminations. So this is my design propositions. The base structure itself consists of a 20-feet shipping containers using a telescopic mechanisms. As you can see in the features, there's 2 extension elements encompassing within the base structures. It can be collapsed. In this design, this shows the mechanism diagrams that how the element works. In this design, it also features one novel design called the flexible bellow to achieve the structurally seal at all time. So in my design, what I'm aiming for is that I want to achieve roughly 3 times the initial floor space. Yes, and in my design, actually, I have tried to achieve maximum floor height and stuff. Certainly, there's a lot of leeways, but yeah, I mean, as you can see, in order to one of the things that is novel in this, I also propose several features like how I installed the biggest equipment into it prior, so that whatever spaces is expanded will be served for the lighter equipments that can be moved from the storage rooms and stuff, have embedded within the base structures. Yeah. So this concludes my I have feasibility studies, and these studies is used as the foundations for my further engineering works. Yeah. So yeah, thank you.
Thank you very much for your presentation.